Thanks, Jeremy. And before I start, I have to apologise that the Sky Notes is extremely mundane, and following the last two talks, I'm only going to be talking about stuff that's about 4% of the universe. But I will be talking about some amateur observations of a black hole, which is quite an interesting thing that amateurs do. Before I start, I just wanted to mention this, and I hope many of you have seen this on the BAA website. This is our BAA member pages now. If you're a member, you can sign up and you can basically put up your own portfolio of observations or any thoughts that you have on publishable thoughts anyway on astronomical subjects or the BAA. It's very useful for me, this. I've managed to get quite a few images off this that I'm going to be using in the Sky Notes today. So I really do encourage you, if you're not already using this, go onto the website, sign up, and basically start using it as a way of sort of publicising your observations amongst members. I would say, though, as director of the comment section, that please also send your observations to the relevant section director as well. Okay, so Sky Notes for December. This is a lovely picture from Gordon Mackey up in Caithness. Gordon takes some absolutely fantastic images, but this one I thought was a really nice one to sort of act as the intro slide for the Sky Notes. When he took it, he didn't really think that it would come out the way it did. So this is a lighthouse, obviously. Time exposure, you can see the plough there nicely in the winter sky. And basically, as the light rotated in the lighthouse through the time exposure, you got this really kind of impressive, spooky radial structure. So a really nice picture. And Gordon's shots from up in the north coast of Scotland show that actually the weather up there is generally pretty good for astronomical observing, and of course they have really dark skies apart from the odd lighthouse. So what's the sun doing at the moment? And in colloquial language, bugger all. It's the sun is very quiet, not a lot going on at all. This is a SOHO MDI white light image, continuum image from yesterday evening. Nothing really. There have been a few small spot groups though recently, and this image from Peter Taylor was taken back on the 4th of December. A few smaller groups there, but nothing really very exciting. But the thing, of course, these days, and I always say this about the sun now, is that if you observe in monochromatic light, so hydrogen alpha, you can always get something interesting to look at, even when the sun is quite boring in white light. And Carl Barron takes lots of really impressive high-resolution images using a webcam and H-alpha filter. So really nice view here of that small sunspot group with quite a lot of the granularity there as well. This is from Alan Halsey. This is a nice prominence on the limb back at earlier in November. So again, really, it is the case that the sun, even though it's quite boring in white light, there's always something interesting to see in H-alpha. And of course, all those charged particles that stream off the sun still interact with our magnetic field and are still causing aurorae at a reasonably low level recently. But this is a really nice time lapse that Denis Brzezinski sent me from a couple of nights ago. This is taken from his observatory at Port Mahomet, which is actually about 80 miles south, I think, something like that, of Gordon Mackey on the north coast. So Denis is on the east coast between the Moray and the Dornoch Firths. These are the horizons he's got. So this is looking north up to the Caithness in this direction. You can see the nice constellations of the winter sky rotating around the pole, which is scarily high in the sky at his latitude, 58 degrees north. This is a kind of fairly quiescent aurora. The lighting that you've got in the foreground there is from the moon. This was a couple of days ago, so the moon was quite large gibbous, illuminating the land and the sky. But you see the moon's setting about now. So the foreground gets darker, the sky suddenly gets a lot better, and in fact the aurora becomes more active as well. So you've got some really nice activity here. And even where Denis is, there is some light pollution, but hardly anything really. Got a lovely view here of the Milky Way coming down. So a really nice time lapse. And People go to La Palma for really good skies, and I've been on La Palma, really good skies, but also from where Dennis is, when the skies are transparent, they are absolutely fantastic. Another thing you notice, which is very different from down in the southeast, is that there are hardly any aircraft contrails and hardly any aircraft lights in the sky. And that makes a big difference too. So if you want a really good observing site, northeast of Scotland is the place to go. It's not a place to go for warm summers or warm sunshine, but really good dark skies it has. Very, very good. So just starting then in the evening sky, about 5 o'clock, it's getting dark. And there are 2 planets on view at the moment. There's Venus, which is very bright, which I'm sure everybody has seen in the evening sky. It's moving towards its greatest elongation in the middle of January. There's also Mars over here, which is much fainter and essentially is moving towards conjunction now. It's a long, long way away from us. It's on the other side of the Sun from us and moving back in towards superior conjunction, which is next year, next summer. So those 2 planets are there. There's also Neptune, which is not far from Mars actually, and on the 30th or 31st of December is only about half a degree from Mars. So a good opportunity if you want to find Neptune in the sky is to find Mars, and it'll be in a similar wide field. But one thing I wanted to talk about, which isn't a planet, is this thing up here in Cygnus, Gaia 16AYE. And we've had a lot of talks about the Gaia spacecraft. It's a spacecraft that's doing a fantastic job basically measuring the position and proper motions of 1% of the stars in our galaxy. But one of the other things that comes out as a byproduct is it's been detecting a lot of variable stars, and it generates alerts, and those alerts can go out and amateurs can actually do photometry on these objects. And this particular one, the alert was in the summer, came out in August, and observers started observing this object, and it fairly quickly became apparent that this wasn't a variable star, but what it was a star where a very massive object was going almost exactly in the line of sight between us and the star. So this is a microlensing, a gravitational lensing event. And amateur observers have done a lot of photometry on this. And it's one of those cases where I think it really just shows how incredible it is that as amateur observers using relatively small telescopes in our back gardens, we can provide the information that professionals use to do some really impressive astrophysics. So this is the light curve of this object, which is a pretty extraordinary light curve. Shall I install Adobe Acrobat? No. It's not as bad as last year when it was asking me to upgrade to Windows 10 during the Sky Notes. So yes, a pretty extraordinary light curve. So it's just a normal star, nothing much variable about the star, but it's inferred that this is something like a 10 solar mass black hole that just happens to be going through the line of sight of this star. And this is a really nice model that's been made from, I think it's Warsaw University Observatory. Based on, prior to the Gaia detection, these are Gaia results. And then following the Gaia detection, there's a lot of amateur results here in various different wave bands. And this model allows, or the light curve, basically fitting the light curve allows you to infer a lot of stuff about the object that's going in front of this star. So I think the best theory at the moment is certainly a very massive compact object, probably a black hole, about 10 solar masses. And what was really interesting is the model was able to predict, so these things are called caustic crossings, so essentially you get a very rapid change in brightness of the star as it goes through these, because the star, the lens is like a lens effectively, and what you're doing is you're going through points where effectively all the light is then concentrated into a small area and then spreads out again. And they were predicting the second caustic crossing somewhere around November the 15th. It actually happened on November the 22nd, but amateur observers were observing this all the way through. We were quite lucky in the UK that we had relatively good weather through this period. And this is a really nice example of what happened to that star. So this is from Steve Fossey's group at UCL, so it's actually just up the road at Mill Hill. So it shows you really can do astronomy in London. Steve Fossett, and of course, and his students were the ones who discovered the supernova in M82 a couple of years ago. This is taken with the same system, showing the star on November the 21st, and then on November the 22nd. So a really good example of real cutting-edge astrophysics, but done mainly using observations made by amateurs. Obviously relying on Gaia to find the thing in the first place, but really nice. And there are more and more examples now of this, these gravitational microlens events. So, yes, back in the evening sky, we had a really nice conjunction of the Moon and Venus back in early December. Venus, currently a gibbous phase. It's moving out to maximum elongation next month, but it's kind of dominating the early evening sky, low in the west. It's quite a low southern declination, so not an easy object to observe, image. Mars is still there, but very small, moving away from the Earth. It's only something like 6 or 7 arc seconds in diameter. This is a really nice image taken by Martin Lewis, St Albans. You can see some detail there, and you can see one of the polar caps. These are some drawings by Paul Abel of Mars, again with the diameter of Mars down at about 6 arc seconds, kind of a really challenging object to see any detail on the surface. Of course, Mars was in the news for another reason. This is the ESA ExoMars spacecraft that was consisted of 2 parts. You've got the Trace Gas Orbiter, which is the main mother spacecraft, and you've got this little lander called Schiaparelli. And I think we all know what happened to Schiaparelli. Unfortunately, it made a really large crater on the surface of Mars. This was a very costly software error. One of the things about Schiaparelli is it was an engineering demonstrator, but it certainly demonstrated one thing, which is that software is something you need to get right. So what happened with Schiaparelli is that we've got radio recordings from TGO that show that everything went well right through to the parachute deployment and almost to the point of the parachute separation. But there is an accelerometer in the lander, which is part of an inertial measurement system, which is used as part of the lander navigation system. And that accelerometer was subject to greater acceleration than was expected and led to the saturation of some measurements for the accelerometer, which you think wouldn't be too serious because the software would be able to handle that. Unfortunately, the software didn't handle it. That saturation basically led into the navigation model of the lander and polluted the navigation model such that the navigation model thought that the lander was actually beneath the surface of Mars when it was still 3 kilometers up. This is another planet that's in the evening sky, Neptune, kind of disappearing now, but this is an image. It says, oh yes, so this is November 23rd, quite a nice image of Neptune and its large moon Triton. And as I say, Neptune is actually in conjunction with Mars on the 31st of December. So a good opportunity to find the planet then within half a degree of Mars, which is pretty easy to find. Just wanted to show this. This is another lovely image by Gordon Mackey. The excuse is that sort of in the evening sky, Cygnus and Lyra and the summer Milky Way are still there. This again is just a really fantastic example of how dark the skies are up there in the north of Scotland. And a really nice image as well. This is a panorama of 50mm focal length shots. It's a very large image. I've got a much higher resolution image of this, and it's just fascinating scrolling through it and finding all of the deep sky objects that there are there. So, moving around a little bit later in the evening, around about 8 p.m, we have the kind of autumn constellation still there, so we've got Pegasus and the Andromeda Galaxy up there. Planet Uranus is just past the meridian at that time of night and at a reasonable altitude, so people have been able to get some fairly decent images of Uranus and its satellites, which, considering the diameter of Uranus is only, what's it, about 3 or 4 arc seconds, something like that? Yeah, is pretty remarkable that we're getting images like this. So Martin Lewis again on the left and John Sussenbach on the right. And you can really see detail there on the surface of Uranus, which is pretty extraordinary, I think. Moving around a bit further, so about 11 p.m, we've got the winter constellations coming into view. So of course Orion is the constellation that dominates really through the winter, you know, a constellation that anyone can recognise. Probably after the Plough, it's the most recognisable constellation around. A couple of things on this chart. We have the Geminid meteor shower coming up, but we also have, and I wanted to plug this for Mike Harlow, who is now the Variable Nebula Coordinator of the Deep Sky section. We have NGC 2261, which is better known as Hubble's Variable Nebula. This is an image I took of it a couple of weeks ago, and it's always worth keeping this object under observation, looking for variations, as this star here varies the actual structure of this nebulosity appears to change. So I'm sure Mike Harlow would be very pleased to receive any observations that you can make of this object, whether you make them with your own telescope in the UK or whether you're using remote telescopes. So yes, we've got the Geminid meteor shower, which is really the best meteor shower of the year, much better than the Perseids. It's just it tends not to be observed as much because it's a colder time of year. Unfortunately, this year it coincides with full moon, which is a real shame. So it means that our very best meteor shower is going to be pretty much wiped out by the full moon. That's probably true for most visual observers, but a lot of meteor observers these days are using video cameras, and they actually work pretty well even when the moon's around. This is actually not a Geminid, this is a sporadic, but this is a clip that Denis Brzezinski sent me a couple of days ago of a fairly bright meteor passing almost kind of in front of the moon. So those people who are using video cameras should still hopefully get some decent results from the Geminids, assuming that we get some clear skies. More and more people are using these high sensitivity video cameras to do meteor observing, and I've got 2 of them, and I'm really impressed how many different things you get, and I actually got this the other day. So I think this chap had obviously been eating some of the fish in a local pond somewhere, and he decided he was going to stop there. It makes a change from cats. I normally have cats who come along and then eat the spiders who form webs across the front of the camera. So if you are thinking of setting up one of these meteor camera systems, then you don't just get meteors, you get lots of interesting wildlife as well. I think sometime, Alex, we ought to do a kind of paper for the journal on wildlife caught by meteor cameras.
We have quite a collection between us, yeah?
We have, yeah. Okay, so moving a little bit further around then into the morning sky, we've got in the morning sky the sky is really dominated by Jupiter in the southeast. We also have the interesting variable star R Corona Borealis, nicely visible in the morning sky. R Corona Borealis is that star that essentially surrounds itself with soot every now and again and goes from being a star that's naked eye to being a star that's very, very faint. It's been in a faint state now for many years, but it does seem to be struggling back to naked eye visibility. So this is a light curve from the VSS light curve generator, which shows it coming up reasonably well. Gary, what do you predict it's going to do over the next 6 months or so?
I'm not going to stand here and do predictions in front of everyone. I predicted it might be on unpredictable.
Yeah, okay. I think that's a good prediction. Unpredictability seems to be one of the things that it's doing. So after a very long faint period, it does seem like this star is struggling back to its normal brightness. But we'll see what happens, and maybe when I do sky notes next time, we'll be able to know what's happened. It'll have done something completely different to what we expect anyway. So yeah, Jupiter dominating the morning sky. This is a nice picture of the conjunction it had with the crescent moon back at the end of November. This is by Steve Brown, and you can see there the Galilean satellites of Jupiter nicely in this, and the moon with some nice earth shine. So a really nice photogenic image there from Steve Brown. Okay, so we all know who took this. This is Damien Peach. This is one of his movies of Jupiter, taken from. When Jupiter's at its best, he always goes off to Barbados. Is it Barbados? Yeah, Barbados, and generates terabytes of images, and then comes back and spends the rest of the year processing them, and then sort of in October sends everyone these extraordinary movies that he makes. But anyway, yeah, this is Damien's amazing rotating movie of Jupiter taken in March, taken with an amateur telescope, a 14-inch C14 in Bermuda with a webcam. It's pretty incredible stuff, and it seems to get better year after year after year. I mean, if you just look at the detail in these belts, it's just extraordinary. But anyway, Jupiter is actually in the morning sky. As I say, it's coming back now, although it's been quite low, coming out of conjunction, quite difficult to image. It's of particular interest to professionals at the moment because the Juno spacecraft is in orbit around Jupiter, and that spacecraft has had some issues of its own, but seems to be working reasonably well now. And this is a slide prepared by John Rogers showing an outbreak in the North Equatorial Belt of Jupiter with some Juno images and some amateur images. So again, the note goes out that professionals are very keen to receive amateur images of Jupiter. Whilst professionals can get high resolution images using large telescopes and Hubble, they can't get the time resolution that amateurs can get. And so they're very keen to get images from amateurs, particularly for these kind of time-sensitive events. So we'll move on to comets now. So still things in the solar system, but rather more fuzzy and diffuse. Somebody was complaining to me recently that in my first year of comet section directorship, I haven't actually provided any decent comets to observe. I do apologise for that, but there's not a lot I can do about it, really. Anyway, there are some comets around in the morning sky that imagers can image and are comet-looking things. They're not just very faint, fuzzy blobs. They've actually got tails. And potentially there may be some binocular comets coming up in the new year. So this is one of the comets that's currently in the morning sky. This is C 2015 V2 Johnson. This is an image I took of it back at the end of November. You can see it's got quite a nice tail there. It's currently relatively faint, but it's brightening up, and it may become a reasonable comet in the new year. It's a comet which is what's called a dynamically new comet. So its orbit indicates that it's its first visit to the inner solar system. And comets like that are generally the comets that lead to disappointments, because they are fairly active far out, and then when they come into the inner solar system, they don't live up to our expectations. So anything I say about prospects for this comet, please take with a big pinch of salt. And when we have our next sky notes, please don't complain if it turns out not to be as bright as we think it might be. So that's one of the comets that's in the morning sky at the moment. That was discovered quite a while ago, back in 2015. This is another one. This was discovered much more recently. This is 2016 U1. Neowise, and there it is there. This is an extremely diffuse comet. It's quite a fast mover, but it's extremely diffuse, and that means it's an extremely difficult comet to estimate its brightness or magnitude. And there are lots of discussions, and discussion's a polite way of putting it, on various comet fora, about how bright this comet is. Because it all depends on how good your skies are as to how far out you can trace this coma, because the integrated brightness depends on essentially how big you think the coma is. So we've been doing some measurements from the pristine dark skies of Southend and Chelmsford. But interestingly, comparing them with the dark skies up at Dennis's in Talbot Ness, we're getting similar results. So this comet's somewhere around 13th magnitude at the moment from CCD observations. Some visual observers have said it's as bright as 10. But if you take our CCD observations and some of the more realistic visual observations, it may get as bright as 6th magnitude as soon as this January. Now, it's an interesting comet because generally we have a really long sort of advance warning about when comets are going to be bright, and this comet's almost come out of nowhere. It's a fast mover, it's a very small gassy comet that just happens to be going very close to the Earth. So this might be a reasonably good comet going into January. It becomes increasingly difficult for us to observe as it gets closer to the Sun. This is a lovely image by, it shows a Chambio showing both of those comets, Johnson V2 over here and Neowise U6 over here, next to M51. So they put on a really, no sorry, it's that one, it's Neowise, yes. That's not. They put on a really nice show. Because Neowise is moving quite fast, it wasn't there for very long, but it's definitely, if you're in a reasonably dark site with a DSLR, it's something which you might want to have a go at picking up on a DSLR image. It'll show up as the sort of characteristic greeny colour that you get with comets from the Swan Band emission. So this might be a reasonable comet in January or so. This is another comet that may possibly become something in the coming year. This is comet 2015 ER61, discovered by Pan-STARRS. There it is. This was when it was very faint, but it could brighten quite rapidly in the coming year. So there's a list of comet prospects. If you actually look in the current journal, there's a nice article from Jonathan Shanklin about prospects for next year. He maintains this list, and this list was updated recently. The article in the journal, I don't think, mentions 2016 U1. Because it wasn't discovered then. But essentially we've got the prospect that ER62 could be reasonably bright for us in June, and by reasonably bright here I'm talking about 6th or 7th magnitude, so nothing really spectacular. Johnson as well could reach about 7th mag in the early part of the year, and U1 could again reach about 7th mag in the early part of the year. So comets worth looking out for, but they're not going to be spectacular. They're kind of better than the current crop of comets, but they're not going to redeem my reputation as director by any means. One other comet I just wanted to mention is an old one. This is a comet that was discovered by Roy Panther on Christmas Day in 1980. This is comet 1980 Y2. Roy Panther discovered this comet after about 650 hours of searching. And this picture taken by Ron Arbour is one of the few pictures that there are of it that I could find. But Roy died recently, and he was the last living visual British comet discoverer who discovered a comet visually. So there is no longer anyone living, a British person living who has discovered a comet visually. So Roy was kind of in that very special position. This is a picture of him receiving his Merlin Award from Leslie White at Hawkston Hall in 1981 with a very characteristic 1980s blazer. This picture was taken by Ron, and then quite a bit later, this is Tom Bowles with Roy, taken at George Alcock's funeral. So basically now, no comet discoverers, visual comet discoverers alive from the UK. One of the things about Comet Panther was it passed very, very close to the North Pole. This is Polaris here, and you can see there's two fuzzy blobs here, which are two pictures of the comet taken on 2 consecutive days. It actually passed within between Polaris and the North Pole. So that was quite an unusual thing, but it gives me an excuse to show a really nice time-lapse video that Nigel Evans did of an asteroid, 2003 YT1, that also passed between Polaris and the North Pole. There it is, at the beginning of November. So there you go. That's quite neat, I think. And it's a good example of how the track curves because of it being an Altaz shot. So there you go. So that was an event which actually wasn't very much publicised, but which we had a nice clear night, and Nigel was able to get those images. So just to conclude then with a couple of supernovae from Ron. So Ron Arbour has discovered 2 more supernovae. They're kind of characteristic of Ron. This one particularly, it's kind of very close to the centre of the galaxy there. And obviously it's Ron's year of the dragon, because both of them are in Draco. So this one is in UGC 10502, and then more recently he discovered this one. And there you go. So this is his discovery image. In fact, it's interesting when you see Ron's discovery images, because obviously the images that we usually see are much longer exposures, like this one. His discovery images are like this. So he's going through hundreds of galaxies a night to discover these supernovae, and there you go. There it is. And as everyone says, it's a lot easier when you've got these pointers on there. But if you imagine that they weren't there, and you're looking for a supernova, it's really hard work. So congratulations to Ron for that. He sent me a much deeper image showing these two interacting galaxies and the supernova there. So then just finally, before we finish, the Geminids are wiped out, unfortunately, by the full moon, but we do have one other meteor shower that's worth your time, and that is the Quadrantids, which peak on the 3rd of January. So after all the excesses of Christmas and the excesses of New Year's Eve, you want to be out there in the dark, clear, cold nights on the 3rd of January looking at the Quadrantids. It's a meteor shower that actually has reasonable rates. The moon is out of the way this year. Effectively, it's a crescent that sets before midnight. So this is actually an opportunity to do some proper visual observing to effectively atone for all of those excesses over Christmas, when unlike Roy Panther, you don't go out on the night of Christmas Day to discover a comet. So thank you very much, everybody. Happy Christmas and prosperous New Year.